Anything you say can be and will be used against you in a court of law. I have evidence.
I'm glad my head.
So, proof by contrapositive. This was one that was like kind of poorly done in the last exam, I think. And it's got a few moving parts and a few elements, so we'll get into it. First of all, we need to understand negation, and we need to understand negation with regard to ands and ors, so multiple things happening. So we need De Morgan's laws. We'll get to that in a second. We'll look at negation first. Negation is the exact opposite of a statement. So it can get a little bit confusing, so I'm going to clear something up. If we make a statement, the sky is green, it's obviously false, but a statement like the sky is blue is not a negation of the sky is green, despite it being true. Okay, negation is always the antithesis, the exact opposite of the original statement. So the easiest way to do that is just to put a not in front of your statement. So instead of the sky is green, the sky is not green. That covers every other color. Yeah, so the sky is red is involved in that, the sky is blue is involved in that. It's much easier to do it that way. And a statement and its negation, one of them is always true and one of them is always false. Which is why it's so important to do not, because if you just say a negation to the sky is green, is the sky is red, neither of them are true. So one of them has to be true, so the sky is not green is true. You can also say 1 plus 1 equals 2, that's true. So when we negate it and say 1 plus 1 is not equal to 2, that's the falsehood. All prime numbers are odd is false, because 2 is an even prime. Therefore, the opposite of that is there exists an even prime number. Not all prime numbers are even, or some prime numbers are even. The negation is there exists at least one that is not odd, or is even. And all triangles have 3 sides is true, so the negation is some triangles do not have 3 sides. There exists some triangle. Now, we're not today are we going to get into the there exists and for all. That'll be a future lesson. Today we're just looking at negation. So I just want to make it super clear before we start. When you negate, just put not if you're unsure. Yeah, even if like the opposite of odd is even, but if you're not certain that's true for whatever reason, you're having a brain meltdown, not odd. Totally fine. Okay, so we're going to jump straight to De Morgan's laws and start talking about that. If we have multiple things happening, so in this case, P and Q, if we're saying it's not P and Q, it's the same as saying it's not P or it's not Q. Okay, so if it's both, we're saying it's not both. It's either not one or not the other, and that's proven. If you can prove one of them's not true, then you're sweet. Whereas it's a bit harder to disprove, I suppose, when we get to that. It's a bit harder to disprove something like not P or Q. Not P or Q means not P and also not Q. Right? P or Q just means it can be one or the other. So if I'm proving it's not one or the other, I have to prove it's not one, and I have to prove it's not the other. If you want a shortcut, you shouldn't use a shortcut, you should use logic. But if you need a shortcut, if you're knotting an and, it turns into individual knots plus an or. If you're knotting an or, it turns into individual knots again, but it's an and. So they kind of just flip. And that'll become important when we start doing knights versus knaves. Don't roll your eyes. Alice is going to get involved. They'll come back to that. Okay. All of that's going to will become important because we're going to be looking at proof by contrapositive. And contrapositives involve 2 things, and it involves negation, which is why we need to cover those briefly first. So if we have a statement, if it is the end of term, then the students are happy. The contrapositive to that is you flip the hypothesis and the conclusion and negate both. One of the things we made errors in last year was we were negating just one of them. We need to negate both for a contrapositive because they are logically equivalent, right? If it is the end of the term, then the students are happy. Makes sense? And so if we flip them and say, if the students are not happy, so we negate the end one, then it can't be the end of the term. So it's not the end of the term, which makes sense as well. Not saying it's, yeah, it's because if you were, that's to say, if this is true. This is obviously false. If it's the end of the term, the students are happy. Because you would be sad if it was the end of the term. Correct nodding. Yeah, exactly. So, all we're saying is that if the original statement is false, which this one is blatantly, if that's false, then the contrapositive is also false. If that's true, then the contrapositive is also true. They're logically equivalent statements. So, the point of this is sometimes it's actually really, really hard to prove a statement true or disprove it and prove it's false. But sometimes its contrapositives really easy to prove and much less time intensive. Okay, we'll look at some of them as well. So first we'll get in the habit of writing the contrapositives correctly. That's important. And then we'll look at proofs. Okay, so let's just go to the questions in the textbook and say, yeah, we'll do question 4 together. So you don't need to prove any of this. Some of them you can prove, some of them you can't, but I don't want you to prove any of them. I just want you to write down the contrapositive for each of those statements. So remember, you're flipping the hypothesis and conclusion and negating both. And I'll just do F on the board. Before F.
Wait, do we write down the original and the...
Yeah, probably. Yeah. Write down the original and then write the contrapositive underneath. It'll help in your revision to see both in action.
So, do we swap the clauses around? I forgot. Is it like if it's not raining, then if there's no clouds, does that turn to if there are clouds then it is raining, or does it just go and
switch both and negate both?
okay, switch both and negate both. Oh, you have to restart. Oh, look at that.
Should we run?
It's
Well,
called
that's
simple.
one where it's like, if you're smiling, you're happy.
Yeah.
And then we just say like, if you're not happy, then you're not smiling. Or
Yes.
do you do like, if you're
That's it. Not necessary.
It's not like really...
I would just use not if you're unsure, because it's unhappy
I don't know if that's...
than negating happy.
Yeah, that's what I mean.
Because not necessarily, because I could just be like, meh, I'm not unhappy, but I'm also not happy. So I would just say not happy. Keep in mind, these are not necessarily true statements either. Not necessarily, because I could be smiling and be dead inside.
Yeah. That is
Like this.
literally every day.
Looks so happy, so...
Yeah, I'm
It
so
looks like
happy.
you just like, lost the lotto or something.
Yeah.
Big time.
I'm fine.
I gambled all my earnings away.
Yeah, just spent millions of dollars on it.
For
That's
the
fine.
camera. Wait, are we proving the contrapositive or disproving the contrapositive?
You're not proving any of them. Just write the contrapositive.
When we get to
That's a great question. It depends on what the question asks, I suppose. If it asks you to disprove, you will disprove. But if it's just asking you to prove it, then you prove it, I guess. Depends on the question.
Okay.
For D, is do they change to greater than or greater than and equal to? Like,
Greater than or equal to. Has to be everything other than, sorry, less than or equal to.
yeah.
Has to be everything other than greater than.
Isn't that less than?
No, that's greater
Well,
than.
greater than and then be less than equal to.
So that's greater than.
And then you flip it.
I
And
thought
then
that
put
way
the-
is less than.
Yeah.
Oh no, that way is less than.
No, that way is greater than.
The arrow points to the bigger number.
Yeah.
No, it points
No,
to the smaller
The
number.
alligator eats the
bites
bigger
the-
number.
The alligator,
It eats the bigger
Actually, no,
number.
it's a
So
crocodile.
it's greater than.
That's what I
Greater
said.
than.
no, whatever works for you.
So the when we define whether it's an integer or not, that doesn't matter in terms of the contrapositive. We don't say like instead of an integer, it's actually a real number now. Or it's a positive integer,
Ah.
making a negative integer.
No, you do not. That's a good question, actually, but no.
So you just disregard it.
It just, M and N are integers, that's the starting bit. Hence, based on that information, prove this.
Okay.
Or disprove
Can I
it.
prove the original?
Before we get to F, I want to talk about this one briefly, because this would be an instance where the contrapositive is much harder to prove than the original. So I'm not saying the contrapositive is always easier to prove. I'm saying sometimes it can be, which is why we need to know about it, but not always. This one, if M and N are odd, then Mn is odd, is much easier to prove. Yeah, we would just make M and N odd. Might be a good refresher. So M equals 2A plus 1, N equals 2A plus 1.
Wait, so you'd be using the same.
We can make it
term?
different, 2B. Then we've got 2a plus 1 times 2b plus 1, 4ab plus 2a plus 2b plus 1. And what we can do is we can factorize a 2 out of the first 3 terms. So we get 2 lots of 2ab plus a plus b plus 1 at the end. As these are all, like this is going to be an element of the integers because a and b are integers. Yeah, they're integers, so this entire thing becomes an integer. We get 2k plus 1, where k is an integer, which is odd. So that one's straightforward to prove. This, on the other hand, is much harder to prove because all I can start with, if mn is even, all I say is mn equals 2a. And from the 2a I have to get to m is even or n is even. And so if anything, that would be like a proof by case sort of scenario, which is much harder, or not harder, but it's longer and more time consuming than just that. Yeah? So before you just blatantly go ahead and start proving a contrapositive or something, actually think about whether the original contrapositive is easier or harder. Okay, so with these kind of proofs, they're similar to our direct proofs, except kind of in an awkward situation where we've been given kind of like the answer we want and the hypothesis in the wrong spot, which should be an indication for you to switch them over, aka contrapositive. Right, so try and always start with a single term being odd or even, because then you can just sub that in, yeah? As opposed to this whole thing being even, I can't really break that down. So, well, I can, but it's much more annoying to do so. So flip and negate. If n is even, then 3n plus 5 is odd. That's our proof, or our RTP. So we start by saying let n equal 2a, definition of our even number, and then say, therefore, 3 lots of 2a plus 5 is going to be equal to 6a plus 5. And we want this to be an odd number, so we want plus 1 at the end. So I'm going to simplify this first into 6a plus 4 plus 1. So there's my plus 1 at the end. And then I'll factorize out 2. So I get 2 lots of 3a plus 2 plus 1. And I might make an annotation different to that proof up there. I'll say let k equal 3a plus 2, where k is an integer. And therefore, 3n plus 5, which is my thing that I'm trying to prove, equals 2k plus 1, which is odd. Gwen. QED. Right, so probably something actually, can someone offer something I need to add here to make it more mathematically sound? Zachariah?
I don't know.
Alright, someone who has a clue? No?
A is an element of its integers.
A is an element of the integers. Very good. Has to be. Because if it's not, then it's not true. Right, if that's like, if A is like 2.4, which is not an integer, then 2 lots of 2.4 is 4.8, which is not an even number. It's a decimal number. I don't know, is 4.8 even? No, not by definition. We feel like it's even, because it's got 2 even numbers in it. But it's not an even number.
It's not divisible by 2 which would even.
Anything else? Got RTP, got QED, got the what?